Alright, so our next step is to add in some movement for our baddie characters in this game, because right now they're pretty easy to avoid when they're standing at a standstill. So in my original version, the movement that I added in for my baddies was to have them walking around and ticking around in kind of a box or rectangle motion. So for my baddies, that starts, we'll say that it starts in this position right here. I had it walk over some amount to the right, down some amount, over some amount to the left, back to where it started, and then back up some amount. So that was the path that I had for my baddies. We're going to talk about how to do that kind of a path now. If you find that your extension is you're going to have multiple different options of paths for baddies, that's a great idea or a thing to do. But we'll talk about how to make the baddies paths all be the same but not look like they're all moving in unison, where every single one is starting moving to the right, then down, then to the left, then back up, so that they become a little bit more difficult to avoid as the player. So in order to do this, the thing that I really want to think about is I want to think about if this is where my baddie starts and this is its XY position, we're going to have it increase its X. So the first part of the move, first step will be to add to X. Once it's done all of that, meaning it's moved all the way and it's now sitting right here, my next step would then be to add to the Y value to move it down the screen, because remember our Y values increase as we move down the screen. Starts at 0, ends at 600 as you move down, so then we'll increase our Y values until we get to here. Once we get to that point, then my next step from there would be to subtract from our X values to move back to the left. And then finally, once I'm seated there, final step would be to subtract from our Y values. And then, well, we would want this whole thing to repeat. So there's a lot of different ways that we can think about this. When I was making this originally, the easiest way that I had to think about it was I wanted to just have something that would count how far over I've gone in the X direction and how far down I've gone in the Y direction, so that way I could undo those maneuvers in the same way. So I added in two variables into my baddies. I had a count X and a count Y. And the reason I did this is so that way they both start, well, for right now, we'll say they both start at 0, meaning they're here, and then as we increase to the X, now my count X will be adding every single time that I do that, so count X is going to be adding, and then as I move down this way, we'll be adding to my count Y, and then as I go along this way, we'll be subtracting from my count X, and as I go along this way, I'll be subtracting from my count Y, and then we'll start all over again, and that's the way that it's going to work. So what we really want to do is, in order to be able to do this, well, we're just going to say, like, okay, for some amount of time, we're going to add to the X. I'm actually going to want to change this color because I don't want it to be the same as my baddie color. So let's fix that. Come on. I don't know. Let's have it be, do we have one that's green? We do. We can let it just be red. Sure. So then that means that we'll start here. We got a little red dot to begin for when we started. So our first step is to add to the X. So what we really want to do when we're doing that first step is we want to think about if our count X is going to be less than whatever value it is that we're going to stop at. So what I mean by that is, let's say for right now, we'll say if our count X is less than 10, then what we'll want to do is we're going to want to increase our count X. That'll be a step that we want to do in this case. And then that thing that we'll be adding on to isn't actually changing, count X. And that thing that we're adding on to isn't actually changing my Y value in any way. So the other thing that I need to also say is, hey, actually increase your X value, sorry, not Y value. Actually increase your X value to move in that way. This is really to track where your position is relative to where it started, and this actually does the moving. so that way we can keep track of when we've reached the rightmost edge of our rectangle of our pattern, but that way we're not losing or having to continuously keep track of where we started and how we're going and how we're moving from there. So the next thing that we'll then want to think about is, okay, great, now that we've done that, the next step would be to then move in the Y direction. But I do kind of want to do these things in this order. So in order to think about it in that way, the next thing I'd have to do is I want this to be an else-if, in green. I'd want this to be an else-if statement, because if I want to start by just moving in the X direction. Only once that is complete would I want to then start moving in the Y direction. So in order to avoid doing that, at the same time, I have this be an else-if. So if this one is true, then it's not going to jump down and do this one as well. However, if this one's not true, then it'll continue checking these later conditions. So then we would want to know else if, I don't know, let's say our count Y in this case, we'll make it bigger, is less than 20. Then we'll want to do those same maneuvers, but in our count Y direction. And then we want to increment the Y value to actually do the movement and then continue onwards. Okay, I'm going to cut and move these over just a little bit so that we can keep going. A thing that I said before when I was talking about having this count X and count Y is that while I'm moving in this first part, when my count X is less than 10, then if my count Y is less than 20, if I keep going in this way, I do want to change my position, my this dot X and this dot Y, to subtract when I get to here and when I get to here. However, if my next line says if my count X is greater than 0, subtract from it, it's going to kind of start to override with the one that we've got up above. So what we need to do is we need to keep counting up in the X direction of this is going to be 0 to 10. Okay, great. Then this will be 10 to 20. And once we've hit 20, then we'll reset ourselves back to 0 so that I can remember that if I'm doing this one or if I'm doing this one. Because if I subtract 1 from my count X, I start here and I start at 0, go 1, 2, 3, 4, 5, 6, 7, 8, 9. Add 1 more and now I'm at 10. So then I would stop and start doing my count Ys. Once I've done all my count Ys, if I get to here and have my count X now doing a minus, well then from here it'd be at 10, it'd get to 9, and then all of a sudden I'm jumping back to this situation and adding to my X's again. So in order to prevent myself from doing that, I'm going to continue to count upwards in both directions. The thing that's going to be decrementing this time, however, is going to be that X position. So what I mean by that is when we do this purple step, which is that second count X step, we'll continue on it to be an else if statement for us. But this time we're going to want to say if our count X is less than 20. And if that's the case, then what we'll want to do is we're going to want to continue adding to our count X so we know where we're at. Sorry, not just count X plus. However, this time what we're going to want to do is we're going to want to subtract minus for our X values. And once that's the case and we've added all the way up and our count X is now equal to 20, we're then going to be at our last step, our final step, which is the Y values again. So now in orange, my final step would be finally again, else if, and similarly for our Y values, our count Y needs to match our count X. So it goes from 0 to 20. So then this case should be from 20 to 40. Again, we'll continue to increment our counter. So we know where we're at, but we will decrement the location to move in the direction that we would like to. And then my final step, it says here, is to repeat. And what we really mean by that when we say this is reset those count variables so that I would start all over again. So then my last step would just say else. I don't have any checks to do, but if I've gotten through all of these, my count X is not less than 10, my count Y is not less than 20, my count X isn't less than 20, and my count Y isn't less than 40. What that means is when I'm at this step right here, the comment part says, okay, well then that means that my count X must be, well, equal 20, and my count Y must have been equal to 40. So what I would then need to do is start all over, and I would want to reset my count x to be 0 and my count y to be 0. All right, so let's head on over and program this then. Thinking about and keeping this in mind, I'll even add this screenshot over on the side while we program. All right, we've zipped over back onto IntelliJ, so let's start programming this move method for our baddies then. Based on all of the information that we had here, we know that we're going to add in count x and count y variables so that we can keep track of where we are in this pattern as we go along. Remember, count x and count y are ways to keep track of where we are. The thing that is actually going to change in our position is when we mess with our this.x and this.y. So the first thing that we're going to want to do is first we move right. And to do that, we want our count x to be less than 10, we'll say for right now. And then if that's the case, we'll increase our count x to let us know that we are in fact moving in that direction. And then we will also increase our x value. Then the next thing that we want to do is be able to move down. That one is our else if. The next thing we would want to do is our count y is less than 20, we said for right now. But then what we'll do is we'll increase our count y. Oops. And then increase our actual y value to move us down the screen. However, if both of those things aren't the case, else if, the next thing we'd want to do is move back to the left. So that would be if our count x is bigger than 10 but less than 20. We'd want to continue to increase our count x. However, this time we're going to decrease or decrement our x value actually to move us back to the left. And if none of those things are the case, then we have already moved to the right, we've moved down, we've moved back over to the left, so then we are at a place where our count y value is greater than 20, but now will be less than 40 for us, and then that would mean we're in a place where we're going to move up, so then this would say count y is continuing to increase, and my this.y is now going to decrease to move me back up the screen. And if all of these conditions have not been met, then what that means is I am at a place where now my count x and my count y are bigger than 20 and 40 respectively for where they need to be. So that means I'm at a place where I need to reset. So this is the reset version. And this is when I'm going to take my count x back to 0, and same with my count y. Reset them back to 0, which will then, the next time around when I call this move method, start me in at this level. Now, a thing that I do want to be clear with you all, in this case right now, what happens is when I do this move method, I'm only going to move one action and move one little tiny step. So when I call move, it's just continuing to move me along my pattern and my path. However, it's not doing this whole method and making that whole box all in one. And that's the reason that we have these ideas of count x, count y. Without that, it would be really easy to just say, okay, well, x plus 5 first, then y plus whatever, then x plus whatever, then y plus whatever, or minus whatever to move us back to the beginning. However, we only want to do one time step of this full path in that amount of time. So in order to do that, we have to have these count x, count y variables. Okay, the only other thing that we have to do for right now, what we're going to do is we're just going to have our count x and count y start at 0 when we initialize all of our baddies. And then let's see what happens. Let's take this away. We no longer need that off to the side. Let's bring this front and center, and let's run over to our graphics game. We've got everything loading and running in the way that we want. We've actually already put in a call to this move method. However, before that move method was doing nothing. Now, since our move method is filled in, when we run our graphics game, our baddies should actually already magically be moving. And if you notice, they all look like freaky little robots because they move at the exact same time. And the exact same pattern. The rectangle is fairly small right now. We kept it very small on the screen, you know, between 10 and 20 in the distance that they move. And they're all moving at the exact same pace. So it's quite obvious for me as the player to know when they're going to move up and down and left and right. So right now it's not too difficult of a game for me to avoid those baddies. So two things that we're going to do to make that a little bit more difficult now that they are all moving is the first thing that we're going to do is we're going to give them a wider range that they're going to run around to. So now instead of our count x moving 10, our count x is going to move 100, meaning that we'll move 100 to the right and then 100 back to the left. And our count Y is now going to move 200, meaning we'll go 200 down and then 200 back up. So I've just hugely increased that little bit. So let's just double check that now. So now you'll see that I go really, really far over, really far down, finally hit their point where they come back over, and then they come back up. Right now this might be too big for what you ideally want for your game, and also if you notice, those baddies can run off the screen. So if you decide that you want it to make it so that the baddies don't run off the screen, we can deal with that as well. But still, they all are moving in exact unison, which isn't exactly ideal for what we want. So instead, rather than having them all start where they're at that 0 position of their steps, we can randomize where their count X and count Y start so that they are somewhere within their path on that rectangle. It's possible that they'll start at 0, 0, meaning that they should then start to the right, then move down, then back over to the left, then back up. However, once I randomize these numbers, it's also possible that they start at the bottom corner. So they've already done the right and the down, so when it first respawns as a baddie, it'll move to the left to begin. And this will make it so that each baddie has its own unique starting point of this exact same path and makes their paths a little bit less predictable to the user. So we're going to go ahead and randomize these numbers. We're going to use similar ideas that we had before when we did math.random stuff. We need to cast to be an integer. We've got a math.random number, and we are going to multiply it by, in this case, our x value can be anywhere between 0 and 200. So we're going to multiply it by 200 so that it'll be anywhere between 0 and 200. And then same for our y value. It's going to be cast to an integer. It is a random number. And in this case, it's going to be anywhere between 0 and 400. So we'll multiply it by 400 to stretch out that number. And there we go. So now when we try this and we run our graphics game, you'll notice that each of these baddies now seems like it has its own unique path. They are still all running that same rectangular pathway. However, they're doing them at different times, so it's a little bit less predictable for me as the user to know when this baddie right here is going to turn and when it's going to start moving upwards again. And there we go.